this webinar. My name is Jawad Safavi. I'm from Iran as a petrophysicist. It's my pleasure to be in this session, and I have to say thank you to Mr. Nikhil and Petroleum Engineering Association to invite me to this webinar. I have about 15 years old experience in petrophysics and formation evaluation of oil and gas fields of Iran and some other countries, but most of them in the Zagros fields in Iran. Thank you for time, and I want to start my session, but before this, I apologize for my not enough smooth English language. So let's talk about petrophysics. I want to a quick introduce to you about petrophysics, and in the next steps we will go to geological environments. The session title is Formation Evaluation Industrial Scale. I chose this title because in the petrophysics books, we read about petrophysics maybe in the academic scale, and not enough books and guideline for work in petrophysics environment in the companies, oil companies or consultancy. My point of view is about the petrophysics in the format of projects that work in the oil industry in most of oil companies around the world. And the goals that we are pursuing in this short session, as you can see, a brief overview of petrophysics and the use of petrophysical logs in the evaluation of hydrocarbon formations, getting to know the geolog software capabilities and benefits of using it. It's also a review of formation evaluation methods and the steps in the software environment. In short, petrophysics, which is the science of studying in the characteristics of rock and its relationship with the fluid inside the rock, such as liquid, hydrocarbon, gas, or subsurface water. Petrophysics, which can describe the distribution of fluids inside the reservoir rock and estimate the production capacity. This happens by using the combination of different well data, including logs, tests, etc. And again, range of petrophysical results are from the identification of net pay in exploration wells to the optimum exploitation of reservoirs with complex lithologies and pore geometry or other unusual features. As you see, there are some key questions we need to add from exploration to the production phase as reservoir change and are re-evaluated through their life. First is, what have we got? Lithology, is that sand, carbonate, basalt? Which fluids? Gas, oil, condensate? Is that dry? And then we need to quantify how much we need input for deriving volumes, maps, porosity, saturation, fluid contacts. We want to know how we can produce what we have. And also very important, we need that before we have, after all, a limited amount of data to describe a complex geological system. When there is a discussion about investigation, the characteristics of a hydrocarbon reservoir, various departments such as geophysics, geology, drilling, reservoir engineering, and petrophysics should arrive at the correct answer in the precise and correct cycle in cooperation with each other, using the information and results of the studies of all departments. For this, there is a need for continuity and coordination between the data of all departments. Once the structure of a reservoir and the pay bodies are identified, then geologists and drilling department can start talk about where to drill and what kind of rock to expect. Once the fluids, contacts, and pressure, temperature are identified, then again, drilling department and reservoir engineers can optimize the well numbers and place. The link is made from the well to the seismic profile. As seen earlier, the seismic has then a geological meaning. The model can be built, maps expected, and prediction can be made, and volumes calculated. You can see that all departments work with each other. Also, all of them are their specific relations with petrophysical data and petrophysical results. Multidimensional acquired data are seismic 2D or 3D and testing dynamic data. The rest is mainly one-dimension data from the wellbore, such as core and logs. As you know, from those data, we need to get to the 3D vision of the reservoir and its dynamics to be able to accurately describe and estimate its potential and how to produce it. How do we integrate all that? We believe, we as a petrophysicist, we believe petrophysics is an integration tool to receive the 3D vision of the reservoir. Petrophysics has changed after 8 years ago that Schellenberger brothers produced paper logs, and the discipline has evolved amazingly fast and far. Not logs now. Logs and test data are input while acquired and can be used instanced in a purpose-built integration package to link all discipline to optimize decision making. And the main purpose is decision making. Reservoir evaluation is one task now, and the nucleus of its is well data, which the petrophysics analyzes and integrates. Technology allows us to see at a smaller scale thin beds, such as thin beds, and bring it to the 3D visualization. If you who are in this meeting like to be a petrophysicist, it's necessary to know that this particular field requires some special characteristics, including that you must be mentally interested in physics and numbers, as well as having skills related to technology development, be able to 3D visualization in your mind, have the ability to puzzle solutions and put together all dimensions of a reservoir in your mind. And most importantly, be able to be a key integrator in the studied team. Uh, The objective of log interpretation depends very much on the user. Quantitative analysis of well logs provide the analyst with the values for a variety of primary parameters such as porosity, fluids, saturations, fluids type, lithology, and permeability. Uh, for these, there are many parameters can be derived by integration to arrive at values for hydrocarbon in place, recoverable fraction of hydrocarbon in place, and mapping reservoir parameters. Many of users of viral logs are more concerned with the geological and geophysical aspects, such as well-to-well correlation, facies analysis, regional, structural, and sedimentary history. And these items need to logs, but not only to petrophysical evaluation results. Well log is a continuous, as a definition to log data. Well log is a continuous record of measurements made in borehole respond to variation in some physical properties of rocks through which the borehole is drilled. In this slide, you see my focus on petrophysical logs. In this chart, you can see a division of petrophysical logs according to formation evaluation. There are three main categories of logging tools, including nuclear resistivity and sonic tools. And all of these types of case hole, open hole logs may be involved in formation evaluation in open hole case, open hole wells and case hole wells. And formation evaluation targets is gain the petrophysical parameters such as porosity, fluid saturation, and petrophysicist wants to achieve the correct results. And the software is only the utility for working. That main work is in your mind as a petrophysicist. Interpretation of petrophysical logs mainly involves full set, or as other name, full suite logs evaluation, full wave sonic log processing and interpretation, NMR log processing and interpretation, image log processing and interpretation, cement bond logs evaluation, and sigma TDT PNN logs interpretation. Two last items are about only for case hole formats, and the others work on open hole works, open hole wells. And maybe in the image logs and NMR logs, the petrophysicist only process the data and interpretation of advanced data such as full wave sonic NMR image should work as a teamwork in combination with the geology section and reservoir engineering sections. For petrophysical interpretations and constructive assessment of formation evaluation, it's necessary to have a variety of petrophysical logs along with dozen of core analysis results of well tests and report of previous studies. Petrophysicists, by using this information and using petrophysical softwares, should meet the goals in advance and determine to reach the petrophysical study. As you see in this figure, conventional data and advanced log data, core data, well test, and reports and extra data are the database of a petrophysicist. In industrial scale, maybe you have most of this data or a part of this data. Maybe you watch the well with old logs data only, no core data, no tests. Maybe you have worked to new data with the update technology from the best logging service companies, maybe not. But the petrophysicist and the petrophysical software, such as Geolog, IP, TechLog, should achieve the study goals, should receive the tasks from a project that's defined to the petrophysics sections in an integrated study and reservoir characterization of an oil and gas field project. Maybe you work in a consultant company, maybe you are client and should check and approve the petrophysical analysis. Maybe you perform the petrophysical analysis. In all situations, you should work accurate with this from the software that you have, and gain the porosity value, porosity type, fluid saturation, fluid type, fluid contact, lithology, rock typing, flow unit indication, matrix permeability, such as a log, not point, pore pressure, heterogeneity, anisotropy. Maybe in one project, you need to detect the fluid contacts only as your task. And maybe in full field study, you should do all of the tasks to find out the best optimum results with accurate results with low uncertainty. You are petrophysicists. When the formation evaluation is done on an industrial scale, we are faced with limitation of time perform the work. Sometimes with the large number of wells necessary to evaluate and the existence of old logs that need to be evaluated. Basically, petrophysical softwares are designed to perform petrophysical studies, taking into account the time limit, the variety of data, and the usage according to the needs of a petrophysicist. In this meeting, according to my experiences in the field of petrophysical studies and the use of most important petrophysical softwares, which are very well known, such as TechLog, IOP, and Geolog, and even Elan Plus, I prefer the Geolog software. I worked from the first version of this software, Geolog 5.5 to recently from Aspen Geolog. According to the characteristics of its properties for work, I continue the discussion of petrophysical evaluation using Geolog software in this session. I suppose the Geolog is the best software for work with logs recorded from the wells, because several reasons, such as I guess that Geolog is the best in class petrophysical analysis tools because well data management, because of superior graphics, robust data integration, saving time, incredibly user-friendly in comparison with IOP and especially with TechLog. I worked all of these softwares, and when I confirmed the Geolog because of my experience, not because of the advertisement. You see a figure from the start page of Geolog. There are scientific suites in this software, such as petrophysics, geology, geophysics, engineering, that we speak about them. Petrophysics suite of Geolog, including several modules for logs and core petrophysical interpretation in both open hole and case hole. Geology suite of Geolog include modules for correlation and image log interpretation. Engineering suite of Geolog have modules for geomechanic, casing related logs, PLT logs, and formation tests. Geosteering is commonly defined as the use of real-time measurement to adjust the well trajectory to optimally position the wellbore in the reservoir. Programming, or other name, Loglan, is the Geolog log processing language and provides the software development kit for Geolog. In recent versions, you can give the Geolog the Python codes. This helps is a guide to writing programs in Loglan, MATLAB, or Python for Geolog users who wish to develop their own modules for log processing and database access. And the Geolog geophysics functions provide you with the ability to create and graphically display synthetics, primarily for the purpose of evaluating the seismic well type. When we go to petrophysics suite of Geolog, we have two options for formation evaluation based on two methods of petrophysical evaluation, formation evaluation, deterministic and probabilistic. We have determined module for deterministic methods and the probabilistic methods called Multimin. Determin is a comprehensive suite for a suite of individual modules. Sorry for disconnect. Have you my voice? Suite individual modules that allow you as an analyst to apply all the major modern petrophysical models in a traditional deterministic analysis methodology. All common techniques for shale clay volumes, porosity, saturation, and lithology determination are included. Interactive parameter picking and multi-zone multiple analysis provide a rapid workflow for formation evaluation. The petrophysics menu lists various modules to perform deterministic analysis. Conceptual models incorporate total and effective porosities and saturation as illustrated in this figure you view. But we in oil industry of Iran, most of projects, it's better to say all of projects work with probabilistic methods. In Geolog, in Multimin modules of Geolog. To use the Geolog Multimin functions, you should have some understanding of industry data types, such as a wireline, core, and XRD, and so on. And also have the true knowledge of the Geolog well application. The inverse solution for parameter optimization is available via the Nimble module. These items are selected from the Multimin menu in the processing window. Continue. In petrophysics section of Geolog, we have a core analysis module. And the key features of Geolog core analysis suite modules include correction of core data to reservoir conditions, calculation of electrical properties, grain size distribution, and LPSA permeability analysis, port route radius calculation from MICP data and permeability, related permeability curves from endpoints, and estimation of Curie exponents. Full wave sonic menu of petrophysics section of Geolog enable you to process acoustic waveform data and utilize the data for various analysis. I don't want to more about these items because this is not directly related to formation evaluation. NMR, similar to full wave sonic, processing and interpretation of NMR logs from different service companies are done using NMR suite of Geolog. And version to version, this part of Geolog is improved. FastImage is a module of interpreting log database and on statistical and neural network modeling methodologies to characterize and predict classes, predict properties, perform similarity analysis. This very, very important module of Geolog help you as a petrophysicist to predict logs. Maybe you have not sonic log in your database of a well. You have density log, you have neutron, you have resistivity, gamma ray, but the sonic tools in the well failed and you have no sonic data. You want to have a sonic data based on prediction, based on neural network. FastImage help you to predict the logs from model logs, such as that will you input to FastImage. And another work of FastImage is in electrophases analysis, MRGC, SEM, KNN, and so methods may help you for electrophases analysis. This module first introduced in Geolog and other softwares try to design a similar module, but the Geolog is several steps going through before them. Another important module of Geolog is the saturation height modeling pack. Core analysis saturation height models are excuse me for disconnection. Core analysis saturation height models are built using the technique of interpolating curve with parameters obtained from capillary pressure curves against an arbitrary z-axis, usually permeability or porosity. Visualization is used extensively to facilitate understanding of each step of the process. At each step, the user is presented with interactive graphics that allow direct visualization of the results for that step. Sigma water provides an estimate of a capture cross-section of formation water based on salinity, pressure, and temperature. PNN log, pulse neutron, and advanced similar logs work in the situation you have case hole logs and after production, and you want to know about such a change of saturation from the drilling time of a well and change of water saturation in a reservoir. Unconventional shell environments have a very low porosity and permeability, which means that flow of gas or oil is restricted. And maybe in the field that you work in your countries, you have this type of reservoir, but not in Iran. We have no shale gas, typical shale gas, and we have no enough data for working such as this modules. And another, the TIMBET analysis. In most of reservoir formations of oil fields, gas fields of Iran, we have no this type of reservoirs that we should work with TIMBET analysis. But these modules are in GeoLog for countries that work with this type of formation evaluations. The flow units or the flow indicator view is a multiple view which provides the graphical methods to quantify reservoir flow. This is a base step of rock typing, and the module are in the petrophysics section of GeoLog. And the last module of petrophysical section is the geochemistry that work on source rock analysis experiments. But my experiences in this type of data is low because my work focus on the logs of the reservoir rocks in carbonate, clastic rocks in oil and gas, not related to source rock and geochemistry. After this introduction, I want to go through formation evaluation. In this chart, the basic steps of formation evaluation by the software can be seen from the loading data in the software. Sorry for the slides. QC of the loaded data, the preparation of the logs for entering the calculations, including the depth shifting, the merging, the necessary editing, and then entering the stage of pre-calculations, and after that determining the basic parameters needs for the evaluation, and then performing the necessary environmental corrections on the logs. At the end, you will see the modeling and petrophysical evaluation using the software. In parameter picking, Archie parameters, mineral detection, log response detection, saturation equation, RW detection works. And data preparation maybe needs to depth shifting, merging, de-spiking, and other functions. I told you about determine, but I want to add, when we view the logs and combination of them, we can find out a relation between the curves. This is the language of logs. Main work of petrophysicists is doing in their mind and there is a direct path to experiences and knowledge of the log analysis. Working with software and applying methods of formation evaluation are valuable when the petrophysicists understand the meaning of the curves during the visual survey. Deterministic method, as you know, uses the equations and formulas step by step, while probabilistic work different. When we talk about industrial scale, we want to save the time of project and reduce uncertainties more and more. Many petrophysicists around the world works deterministic method yet regarding to simplicity of evaluation of target formations, their target formations. Sometimes some small companies uses inexpensive softwares which has no probabilistic modules. I suppose that project's time and accuracy of the results is the key for selection the method. My experience in the oil industry of Iran confirmed me that probabilistic method with geolog software prepare the nearest way to accurate results regarding to the time schedule, and the clients love this method because all the steps of the progress possible to follow and check when we are talking about a field study with several wells. I mean, maybe some of you work with fields with more than 400 wells. In this situation, deterministic has more uncertainty regarding to probabilistic advantages. Numeric inversion modeling by excuse me. You know the workflow of formation evaluation in the software in deterministic or in probabilistic methods. You need to have a workflow from log and core loading in software, quality control of log, data preparation, pre-calculations and calculation the temperature and pressure profile from the top of the well to the TD, parameter picking, environmental corrections based on logging service companies charts, formation evaluation by modeling or by using equations, and creating primary model, optimizing the model with core data, and finalizing the evaluation, and at the end, nimble modeling. Nimble modeling is an optional item in Geolog, and the means of it is numeric inversion modeling by linear equations solves the inverse problem. Response parameters for multiple mineral and fluid volumes on multiple tools are calibrated over an interval. These techniques may prove useful when volumes are well known from some independent source like core or XRD, but the tool response are not. This is optional at the end of petrophysical evaluation. In continue, in my time, I want to share two quick movies. So sorry. After you build a new project in Geolog software, you can see the main page of Geolog in that in one of the slides I show you. In project page of Geolog, you can loading digital data types such as LAS, DLIS, or LIS formats. It's easy by drag and drop the files into the project page. As you see, before loading process, it's possible for user to change the destination set of loaded file. Also, you can check the content of loading file. And some data, such as core analysis, present in Excel or Notepad files. This is no problem. Only needs to open these files, send and copy the content you need to load, and paste in the text import of Geolog. This process needs only identifying header of columns to software and type of data, definition, the type of loading data. And we select the point data because we are loading the core analysis data. After easy loading, we can go to well page of Geolog. This is the technical and most important page of Geolog. In the well page, we access to the loaded data of all wells of our projects. We can change the different windows of well page and design our user-defined workspace. Change the units of the loaded data. Change the name of loaded data. This part is several loaded sets, RCal data, full set data that we loaded in this movie. After this, I want to show you that you can change the workspace easily. You can change some options for Geolog viewing, and when you want to work, in this example, we want to show how we all logs for present and detail view. Geolog knows all logs types. I say this because in some software, project to project needs to identify some famous logs to software. I talk about TechLog. After clicking logs and call layouts, logs can be shown easily in the standard scale of them. And as you see, I collect related logs in separate tracks to design a standard layout. In this example, bit size is not in loaded logs. We can make it in geolog. So easy. I want to show again. And we can use shades between logs, change the colors of loaded logs in the layout, and define a standard layout. So rapid. Now, after shading, we find out that we have a quick problem. SGR values are less than CGR in some intervals. We can correct this error easily, but by write and apply a simple expression that you watch. This is a module, excuse me, for evaluate, for write similar or complex expressions, and define if. In the second version of SGR, this log is correct. And finally, we can define different types, such as geological drilling runs and so on. This process also easily in geolog. You can see that you define top, and define a interval log into the top. And define name and depths. For the first of working interval and end of the desired interval. Regarding my time, I want to show a quick movie about depth shifting process. One of the tasks in the data preparation, log addition of every formation evaluation well. Here you see depth shift process by geolog. NFI log in this example is base log, and we want to shift density log and associated logs regarding to NFI. PEF, DRHO, and Caliper that are from density tool are selected, and then we, by clicking and define each depth shift limitation, easily we can drag and move density log by attention to NFI log. And you have the shifted logs in separate sets. And at the end, I want to show you the Geolog, the latest version of this this software. The main page, project, well, GeoSteer, artist for drawing and montaging the pictures. We defined a project as a webinar name, and I loaded the data, and now click on well. This page is open. I call the wells that I made. By clicking the text, I go to the well that I loaded in the movie that you see. Arcal data, my core data, and full wavelengths. I can call NFI log, use from the tops that I defined. By clicking in the track, I call the porosity of core and change the view and change the scale. This is raw data, raw log, not interpreted. And we show the log data. This work that I show you in some other petrophysical softwares, not user-friendly rather than Geolog. And we can go to technical modules such as Multimin. I can show you the models in one of the industry projects we done. The excuse me. We can check the model. Okay, because of the limitation of my monitor, I could not open the window of the multi-models complete. In equations, we can input the logs and data that want to be in model, and volumes are the desired volumes, such as minerals and fluids that we want to resolve to be a result of petrophysical evaluation. And methods, in the methods, we change the logs uncertainties types and values, and fluid properties can help us to define the major parameters of the reservoir that include in the petrophysical evaluation. Thank you for your attention to